is Jacob Nash with JNGL, and this is video. Okay, I have to get rid of this. Well, I guess I can't use that thing. I'll try to figure it out, but that's something that's supposed to let me draw. But, I'll have to X out later on. But this video is on algebraic proofs. And sorry that I did not make a video in about a month. This whole virus thing is just kind of crazy, so I haven't been able to do anything right now. But now I can. So, this video was made possible by Mr. Shives because I used his video for some inspiration. So, also, if you need more help, you can look at his video on algebraic proofs. So, what are proofs? Well, they're basically how you get from something to, like, what you're trying to get to. So, your proof is like, well, if this happens, then this must be true. That's your proof. But the statements inside your proof have to be true. But here's how we can figure out how we can see if they're true. So there's different types of proofs. And there's an addition one. This is where 2x minus 3y equals 5x minus 3y. Well, now we have 2x equals 5x. Well, that's obviously not true. That can't be true because 2x can't be 5x. But let's just pretend that's a y. That's really just a typo. Or a z, actually, because there's already y. But how we know it's addition? Well, you do see subtraction, but how did those things go away? Well, you had to add 3y. So basically, you can tell what proof it is if you figure out how something went away when you get to the new thing. Subtraction is the opposite. You see pluses, but then the 5 goes away because you subtract 5 on both sides. And then multiplication is you see division, and it seems like each time that it's kind of the opposite of what it looks like. But how did you get to y equals 15? Well, you had to multiply 5 on each side to cancel out this 5 and make it just y, and then that turned into 15. Division, you just had to divide by 12 to get that. That's what you had to do. It's kind of just what you're doing to get to the next thing. But substitution is if z equals 2 and j equals 2, then z equals j. Well, that just makes sense because you're substituting. If you know that they're equal, then you can just say that because it's true. Combine like terms. 5b plus 7b equals 19, and then 12b equals 19. Well, why isn't it this addition? Because it seems like you're adding, but you're only doing it on one side because that 19 stays the same. So that's just combining like terms. Because it's not a like term. You can't do that. The 19's by itself, and then you have this. That doesn't work. Here's some other kinds that there are. Reflexive is if there is k, then k equals k. Well, that's just kind of a pointless thing. Because obviously, if it's k, then it equals itself. But that's all that is. Symmetric, if m equals n, then n equals m. That's kind of a hard thing to say, but you see, it's pretty much like commutative property, and you can just switch it and it's the same. And intransitive, let me wait for that thing to go away. If x equals y and y equals z, then x equals z. And the Mr. Chives, or was it Shives? He described this as two bridges. So like you can do x to y and then y to z, and then y is the bridge that connects them. Hopefully this makes sense. 2-column proofs. So sometimes to show your work, you might need to do a kind of table like this. And the first thing that they'll tell you, like, okay, here's a statement. Now prove that this is true. So the statement that they give you is called the given. So you always have the statement, this is the numbers, and then the reason is why that happened. So if you write a statement here, why did that happen? Well, they gave it to me, that's why. So you can just write given. And then you solve on, and whatever the next thing you do, you write what rule that was. You solve again, what rule that was, And then when you're at the end, you have the final thing where it's by itself. So maybe it's like x equals 1. That's the proven. The given can happen 2 times in the case that they give you 2 different equations. Yeah, there you go. And also, it doesn't have to be just 4 different things. It can be more than one. So, sorry, that was crazy. Now I have to do this, and I can click on this. Because this is supposed to be something. Okay, there we go. So they gave you 5x plus 18 equals negative 7. And then you have to prove that x equals negative 5. So the first thing that you need to do, and who knows if this will even be enough columns, but I can just do this. I don't really like this thing. I might not always do this. But the site that I have used, it doesn't work anymore. Okay, that's very messy, but that's just a statement. So you write given for the reason why that's like that is, because that's what they gave you. That just makes sense. And then right here, now you need to solve the next thing. So we can just subtract 18. We have to do that to both sides. So 5x is now by itself, and negative 7, because they cancel out, but negative 7 minus 18 is negative 25. I think on the first video I did review how to solve things like this, but if you somehow don't understand that. So there you go, you have that. What did we do? We had to subtract, so I'm just going to write S, but that's subtraction. So that's what you did, subtraction. Now we need to divide by 5, and you can't just immediately go from that to that. You have to show that you did divide. It's kind of not a lot of room to do that. But 5x divided by 5, that's what you have to do. And then equals negative 25 over 5. Okay. So, yeah, you had to divide, so I'll just write D. And there is another property I don't think I explained, but there's distributive, when it's like this, something like this, x plus 5, that you just have to distribute. That's what that would be, but that's not in this. So. Anyways, then after that you would get, yes, that x equals negative 5. So we can also tell that this proof is true. They told us that we needed to prove this, and the proof is true. So we can just write proven, because that's the proven thing, and that's what you would write. Okay, there you go. X out, and back to full screen. And the work all went away, so you might have to run the video if you want to see it. But thank you for watching. And if you need more help, it might be hard to reach out to your teacher if you are watching at the time when you're not at school, but you can watch this video again or look at Mr. Shives, and how you know you're on the right video is if it looks like that, if he looks like that. And also, maybe you can email your teacher if you need help, but I hope this helped, and thanks for watching.